Light.
Good afternoon, Mr. Archer.
Hello.
You are currently the host, and when everybody gets here in a few minutes, you go ahead and start.
Okay.
I'm going to put in the chat an improved change that you can make on the Matplotlib.
Okay.
So you only have to change one line instead of three.
Can do. I joined a little early so I could finish my coffee, so I'm gonna do that. But I'm
Still taking coffee this time of day? You're never going to sleep, dude.
I drink coffee so that I don't eat a lot. It's my replacement for food.
It's food replacement, coffee.
Yep.
That's kind of funny.
7.1. All right, should be able to share.
Give that a try, see if it runs now.
Looks good.
Okay, I'll let you get started. You've got about 10 or 11 people, which is probably 70% of those that showed up this afternoon. Rest of them, I think, are gearing up for the Super Duper Bowl.
Yep.
And given that Sunday evening, I guess you got to liquor up now so that you have a good
That's true.
good attitude going by Sunday. All right, everybody, I'm gonna let Josh take over. Like I said in class today, this is a pretty short lab. So don't drag it out by being quiet. If you ask a question, just answer it so you can move on and get out of here and have a good weekend. And I'll see you all next Monday. Have a great weekend. I'll be listening in. Bye-bye.
All right. So as he just said, the lab is very short, but it's I wouldn't say dense. It's just there's a couple important things going on here. And what is that important thing? It is I was going to say fetch request, but really it's web requests. So what do I mean by that? The main thing I want you to understand, well, I suppose before I say that, we've done this code before. I believe both of them. Yeah. We've plotted contour data in Lab 7, and we've done treasure maps a bunch. So everything we're looking at as far as what I'll call the workhorse code, like this and this, we've already done it. So I'm not going to say no need to be confused, but it's definitely something that if you've been paying attention, you should be familiar with. But the new thing is the idea of a GET request. What is a GET request? Well, I want you to imagine, and this is a real thing, that at one point your job is going to be you need to have some files visualized for your clients or whoever has you working as a big data specialist, and you need to make it a live thing. It needs to refresh every 10 minutes, and there's 50,000 files. Well, what you absolutely don't want to do is every 10 minutes, 50,000 times, go right click, save as, open up where it's saved, drag it to where I want it to go, and then be able to run my code. I mean, how long did it take me just to say that? Maybe 5 seconds? What's 5 seconds times 50,000? It's a lot of time. There's no real way. I mean, if you really wanted to get technical, you could, but there's no practical way to make code that will do the find the link, right click, save it, blah, 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 blah. But that's okay because we don't need to. What we have instead is the idea of a request. So we have a package called requests, and the method we're going to be looking at is called get. And what does get do? Well, if we've been given a URL, then from that URL, we can get all the data on that web page as a text file. So no longer do I have to right click save as 50,000 times. All I have to do is put the URL into a GET request. And now I can open a file and place the content of that GET. So what we've got going on here, I got to import the request library because it doesn't come default. I've got my URL. What's this URL? Well, it's the gridded data that we've used a bunch before. Now, what I'm actually going to do is I'm going to replace this with nonsense. I'm going to save it. Now, obviously, this is not the correct kind of data, but what I'm going to show you is by running this block of code here, this is where that file is located on the server. I'm going to put out a GET request for this URL, and then I'm going to open up the file that's labeled this, and I'm going to open it in overwrite mode. So it's going to overwrite everything in there. And then we're going to get the content from our GET request, and then we're going to close our connection. All right, so let's do that. And let's check to see if it actually showed up. And there it is. There's all the data. It overwrote the gridded data text file that I have. All right, so I've got the data there, And all I had to do was give it a URL. I didn't have to click, save, do anything. Okay. And the rest of this is something you guys should all be familiar with. So what are we going to do? Well, we want to plot some data in the form of there's 160 rows, 240 columns, and each other position is going to be an X, a Y, and a Z. And this is a 3D plot. So what are we going to do with it? First, we're going to make a list to hold all the contents. Then from there, we're going to open up our file. And we know that there's two kinds of lines here. We got the first one that has 160 rows, 240 columns. And then the actual data here, that's going to have an X, a Y, and a Z. So from there, what we know we can do is if I take the first line, and I split on the white space, I can get my row number and column number. So that's what I'm going to do. And then for the rest of the lines, I'm going to get rid of the white space and then split on the commas. What's that going to do? Well, it's going to get me the X and then comma and then Y and then comma and then Z. So now I have 3 floats representing my X value, Y value, and Z value. What am I going to do with those? Well, I'm going to append them to my XYZ matrix. In fact, let's print it out so we can see what it looks like. It's going to be huge. Yeah, that'll be fine. I was going to say I could just print out a little bit of it, but this will be fine. All right. So I'm going to open up my file, get my list set up, get my rows and columns, and then fill in my list. And here we go. It is a list of lists. You've got an X, Y, Z. Next is X, Y, Z. Next, X, Y, Z. How many of these are there? Well, we have our row number and we have our column number. So we have all the data we need to know in order to fill up our matrix. Okay. After that, we close the file. We always want to close our file connection. And then remember how we had that big matrix full of all the stuff? Well, I want specifically the X values, specifically the Y values, and specifically the Z values. Well, every X value is going to be the first position. Every Y value is going to be the second position, and every Z value is going to be the third. So I make up a bunch of lists, fill them up with zeros. How many zeros? Well, I've got my column and row number. That's where those come in handy. And then from there, I'm going to iterate through rows and columns and fill in my data. So X, I, comma, J is going to be wherever I'm at in my big giant list of stuff, first position. And then Y, I, comma, J is going to be my big list of stuff, second position. And then Z, I, comma, J is the third position. So X is first, Y is second, and Z is third. All right, so let's run that. And then from here, you'll notice that there is a instruction in the chat that Dr. Cleveland posted. If you replace the first line with what we have here, it'll work better. We can contour plot. Now, as I said, we've done this before, but what we didn't do was use a request in order to make this essentially fully automated. I didn't have to right click, save anything, do any funky stuff. Okay, any questions on that? That's the first example we've got. There's only 2. There's not a whole lot here. It's just really important that you understand that what is code there to do? It's to automate tasks so that the computer can do it. Well, what's the task we want to do? Well, I want to right click and save as and put it in the correct folder. Well, you can't really do that, but here's something better. I'll give you the location of the data, make a text file out of it. That's it. You can make more than a text file. You can make a JSON or any kind of XML, CSV you want, but that's what the requests do. You can get, meaning you receive data. You can push, meaning you give data. You can do a whole bunch of stuff. All right. If there's not any other questions, let's look at the second example. So again, we've done this before. And just like we had before, we had a treasure map. And I'll replace this with not a real treasure map. This is just a string. It will definitely not work as a treasure map. But what am I going to do? I'm going to use the request library. I'm going to go to where this file should be. I'm going to use that URL. I'm going to overwrite my treasure2.txt. I'm going to write all my content to it, and then I'm going to close. All right, let's run that. And then open my file back up, and our map's back. Okay. And then everything here is everything you've seen before. This is, I believe, we've touched the treasure maps quite a bit. This was even one of the homeworks lately. And I'm pretty sure you would have seen it on your exam. So we get an empty list for all our information, open up our file, put everything in the file into our list, getting rid of commas. And then we want to get rid of the first row and also get rid of the R's and these dashes. So that's what we do here. And then we run our algorithm to see where the treasure might be. So cell 4-3 contains a treasure. It's row 4, column 3. None of this was new, but this part was quite new. To a new treasure map. I believe it's the same one. Oh, I see. So the only thing we have left is that this finds one treasure. What might we need to do to make it find all of the treasures? Well, let's run through it real quick to see how it works. We've seen this code 3 or 4 times now, so I'm going to go kind of quick. We've got the range for the rows, got the range for the columns. Every time I go through this double loop, I want to increment both. What I want to do is get the first part of the digit, because it'll be like 3, 4. So I want the 3 as the first part. Make that a string. Get the second part, make that a string. And then what is the condition for a cell to have a treasure in it? Can someone tell me? I wouldn't let you get off that easy with not giving at least one question. Row and column number matches the number. Yeah, pretty much. Okay. So here's the condition for that. If this is true, then we print we found a treasure. Found is true. And we break. What would I need to do to make it not stop after we find the first treasure? We actually did this before. It was like in lab 4. I think I just did it kind of impromptu. What would we need to change? Comment out the break. Okay, yeah. So what that'll do is say, instead of breaking out of whatever I'm doing, don't do that. Just continue. Let's see if that's enough. Well, we definitely found more than one treasure. Looks like that's enough for me. But this is nothing new. The new part was using this. That's why it's kind of just lab 7.1 instead of a whole new lab itself. All right, does anybody have any questions on the requests package or how to use it? Wow, I got through this one quick today. Morning took me a lot longer. I guess because I kind of waited around longer for people to answer, but everybody was in weekend mode, so sometimes you have good ones, sometimes you don't. All right, well, let's look at the homework real quick, if it's up. 7.1. All right. Oh, yes. So what we're going to be doing here, very similar to what we did in the lab. It's almost identical. So that was a strange noise. If we consider the first example we did with the contour plotting, this is your magic line section of code that makes your graph. All you have to do is feed in the data. So you have to make X list, Y list, and Z list. Consider this a black box. Why do we call it a black box? Because you don't need to see what goes on inside. All you need to know is what it needs. What does it need? It needs these 3 lists. Where did these lists come from? They came from here. Same thing here. What's the black box? Well, it's this. It's the algorithm that finds the treasure. What does the treasure need as input? Well, it needs our treasure map. It needs this as data. This is the exact same thing. What's your black box this time? It is this. It is a couple lines of code. It's actually right here. This is what will make the visual stuff happen. You don't need to worry about how it works. All you need to do is worry about what it takes as input. So it's going to take, so what are we actually looking at? Is we're looking at time, speed versus time. So let me get my annotation tool. It's just a 2D plot of, you're measuring time, speed. So it's going to look something like this or something like that, where at like 0, you're moving at 1 meter per second or something. You've got values right here to show at time 0, moving at speed 0. At time 3, I'm moving at speed 12. So you're just plotting these. The thing is, we've already handed you a line of code that will plot anything you want. Your job is to fill up the list of the X values, the list of the Y values, give an appropriate string for X and Y, and give an appropriate title. Now, the thing about this is I don't want you to right click and save this. I need you to use a request to get your data, but that's it. It's exactly what we just did in the lab. It's just that the black box is this plotline function rather than the matplotlib we used in the first one or the treasure finding algorithm we used in the second one. So if you understand how to do a request to get the file, then this is trivial. It's literally stuff you've done before with like 3 more lines. Okay, that's might be the fastest I've ever got one done. So does anybody have any questions on the lab, the homework, or anything I've graded? Because this lab for sure, this section for sure is up to date as of today. Do we do the exercise on the lab? I'm not sure I follow. The general procedure for every session is there's going to be a lab where you got to do everything there. And then there's a homework where you got to do everything there. So yes. Someone asked, and again, please don't do it in private message because now I just have to replace it or announce it to everybody. What is the policy on late labs and homeworks? So Dr. Cleveland says, don't bother with the exercise. The example is the exercise. So that's this here. So you don't have to worry about this part. Okay, so I'm just going to answer this question on late homework, and then I'll let you go. I have been giving, there's 3 points: correctness, completeness, and late, and is it on time? Is it correct? Did you do it correctly? Did you turn in all the correct files? That's point 2. Is it late? That's point 3. Is it super late? I'll either take 2 points off or I won't grade it. So it'll be 0. So it is at least one of the 3 points. All righty then. Everybody have a good and safe weekend. Don't anybody do any crazy stunts. Have a good one.